Have you ever found yourself in a foreign country and unable to understand a word being said around you? What if you could bridge that gap instantly just by wearing a pair of glasses? That's exactly what Meta's Ray-Ban glasses now promise with their real-time language translation feature. It's really impressive. Now you can communicate effortlessly with someone who speaks a completely different language. This could be a game changer for so many situations. But do you know how real-time language translations actually work? It may seem simple, but behind the scenes there's a world of complex technology making it possible. Today we will try to break it down in the simplest way possible. At its core, real-time translation follows three basic steps. First, listen. AI listens to what's being said, that is, speech recognition. Second, translate. A model converts the spoken words into a different language. Third, speak. The translation is then read out loud in your preferred language, that is, speech synthesis. Listen, translate, speak. It sounds straightforward, but under the hood there's a lot more going on. Each of the steps relies on advanced AI, specifically a branch called Natural Language Processing, NLP. Let's dive deeper into how the systems evolved and how they actually work. The idea of language translation by machines started decades ago with very basic word-for-word dictionaries. Early systems were simple, rule-based programs that followed hand-coded grammar rules and small dictionaries. For example, translating "I am going to the store" might involve looking up each word and applying strict grammatical rules to get something like
Voy a la tienda.
in Spanish. However, this system struggled with the nuances of human language. Idioms, cultural context, and different ways of expressing the same idea were problematic. The turning point came with the rise of machine learning and neural networks. Instead of hard-coding rules, AI began to learn language patterns from massive data sets, millions of texts and recordings in different languages. Think about how we, as humans, learn languages. We pick up words, phrases, and grammar over time by practicing. AI does something similar, but at a much faster pace, process millions of examples in minutes. One of the major breakthroughs in machine translation came around 2013 with sequence-to-sequence models. Suppose you want to translate the sentence, "I love learning about AI." First, the AI converts the sentence into a set of numbers, a process called encoding. This encoding represents the underlying meaning of the entire sentence. The numbers don't correspond to specific words, but rather the overall idea of the sentence. Next, the decoder. It takes these numbers and converts them into a sentence in the target language, say Spanish. The model doesn't just translate word for word, but understands the context of the entire sentence to give a fluent translation. Sequence-to-sequence models were powerful because they could handle entire sentence accounting for grammar and structure, but they still had limits, particularly with longer sentences where context across the whole sentence is critical. In 2017, a new model architecture called transformers was introduced in the groundbreaking paper, "Attention is All You Need." Unlike sequence-to-sequence models that process one word at a time, transformers can look at the entire sentence or even a whole document all at once. This gives them the capability of understanding broader context, which is critical for accurate translations. The key innovation behind transformers is the attention mechanism. Think of it like this. When translating a long sentence, the meaning of the word often depends on something said earlier or later in the sentence. Transformers can pay attention to the relationships between all the words, regardless of their position, making sure no crucial context is lost. For example, in the sentence, "I gave her the book that she wanted for her birthday." A sequence-to-sequence model might struggle with understanding that the book that she wanted is the object of gift. But the transformer model uses an attention mechanism to pay attention to all parts of the sentence and understand the relationships between words no matter how far apart they are. Transformers are the backbone of today's most advanced translation models, including Google's BERT and OpenAI's GPT. These models are responsible for massive improvements in so many AI tools you see today. So, when you use a real-time translation app, here is what's happening behind the scene. First, speech recognition. The AI listens to your speech and converts it into text using speech recognition models. Second, natural language processing. NLP then analyzes the text, breaking it down into its structure and meaning. Third, translation. Sequence to sequence or transformer models kicks in to generate the translation in the target language, ensuring the meaning and grammar are intact. Fourth, speech synthesis. Finally, the translated text is converted back into speech so you can hear it in your language. This entire process happens in the fraction of a second, but it requires immense computing power. Behind every real-time translation is the network of powerful servers and hardware accelerators like GPUs that process massive amount of data in milliseconds. This is why AI-powered translation tools have seen a rapid increase in quality over the last decade. It's not just advancement in algorithms, but also improvements in hardware. As AI continues to evolve, we can expect real-time translations to become even more seamless. So the next time you use a real-time translation app, whether it's in your Meta glasses or on your phone, remember just how much is happening behind the scene. Okay, that's all for this video. If you like this video, hit the like button and subscribe for more such videos.